So you probably have to formulate a problem. Okay, and also to formulate the goal. Okay, so you have 7 elements under the problem lah. So this one I'm not going to list out everything here. For example, successor functions, the state space, the stack cost, the path cost, right? So I think during the tutorial I already explained. Maybe not all of the group, some of the group already go through the tutorial questions. So I already explained to you how to define the problems and also as well as the goal lah. So you have a goal, optimal solutions, and also the abstractions. So this one you have 7 elements here. Okay, so once we have done the planning, then we move on to the algorithm. Okay, so we go on to the algorithm. So there are 2 types of algorithms here. So one is the blind search, or we call it as a uninformed search. So and then another one would be a heuristic search, or we call it as a informed search. Okay, so blind search is solely depends on the patterns. Okay, meanwhile the heuristic search, it depends on the informations given. Okay, for example, the time, the distance. So we are going to use this information to explore the path. Blind search here we have several quite famous algorithm. For example, depth first search, breadth first search. We have others more like interactive deepening depth first search, so-called depth limit search, bidirectional search. But these 2 are the famous one. So depth first search is you go deeper and deeper vertically. Okay, vertically. Breadth first search, go horizontally. Okay, so depends on the patterns. So what is the limitation for blind search? You're going to waste a lot of time. Waste time and the memory, because even though you know that the solution is somewhere around here, you have to explore also, because it depends on the patterns. Okay, what is a heuristic search? Informed search, it depends on the time. So we have learned about the hill climb. The hill climb here is divided into 2 types of algorithms. A simple hill climb. So maybe it's discussion here. Okay, so we have a simple hill climb and steepest ascent hill climb. Like a superpower, you look back, then no sound. I can turn back, then I go, yes. Okay, simple hill climb is like a depth first search, right? So it explore as long as the parent, as long as the child node is better than the parent's node, then we explore. We explore. So if the child node is worse than the parent's node, then we stop it here. Steepest ascent is we explore all. We choose which one is the best. Okay, then we explore. Let's say this is the best, we explore. Okay, so this is the best, we explore. Okay, if the child's node is worse than the parent's one, we stop here. So the problem of the the hill climb here is local maxima. So this one you have seen, we have a foothill. What else? Plateau, yeah, very good. And ridge, right? And then we improve these hill climbs using best first search. Okay, best first is a combination of a breadth first search and also depth first search. And then after that we have a A star. Right, very good. So best first we use a heuristic cost. A star we use function cost, which is the path cost plus the heuristic cost. So the way they expand are the same now. So last week I already showed you the path, right? How to use the open and close to expand the path. So this is a summary of the chapter 2, 3, and 4. It's about the path search. So now you learn about the path search, you can actually build your own applications. Let's say the Excel puzzle, you can play with your sibling. Okay, see who win the games, right? You know already which path is actually lead you to the least number of stations or least number of steps to reach the goal. Okay, morning, afternoon. Okay, so yeah. So let's move on to the new topic called knowledge representation. It's one of the very simple topic I would say is overall in the 13th chapter is considered a simple one. So forget about this. You can throw this chapter 2, 3, and 4 into dustbin. Before the midterm test, you have to revise. Now you can keep away. So we are going to move on to the new topic called knowledge representations. So in the upcoming chapter 5 and 6 here, okay, chapter 5 and 6 is about NLP. Okay, natural language processing. So I believe you have gone through the practical for NLP. So you know what is NLP, right? Natural language processing. Before we build any NLP, natural language processing, the first step we have to do is to represent the knowledge first. So what is knowledge representation? Is a very important process to organize, structure, and also store the information so that the machine and the human can understand easily. Okay? So what is the knowledge representation? It's a process that used to organize, structure, store the information so that it can be easily understood by human and also the machine. Okay? So why we need to structure the information or this? Because in our real life, there are too many words. There are too many words. For example, happy. Okay, for example, happy, we have excited, we have a sad, we have so many words in your life. So what is the relationship between this and this? So we have to declare first. We have to represent what is the relationship between happy and excited, and what is the relationship between happy and sad. So we have to declare first. So why we need to declare? Because it is easy for the machine to understand. Machines doesn't understand the meaning, the actual meaning of what is happy, but they understand through what? Through the comparison. Okay? I repeat again, machine doesn't understand the actual meaning, just like human. We look at the dictionary, we look at the meanings, then we understand. But the machine no. Machine cannot understand the actual meaning, but they understand through what? Through this kind of mind map, a comparison between this and this. Then they can understand. Okay? So look at this example here. Okay, so let's say now you go to the Google search, it's one of the NLP applications. You ask what is book. So you look at the result here, so you written okay, well, book proposal, what is ebook. Then somehow you will see that why it shows what is the novel. How come the machine knows that book has some relationship to novel? How this works? Okay, and also if you type half an hour, it will return you is half an hour 30 minutes. How does half an hour 30 minutes right equal to 30?
Who the hell asked this question? People also ask what P per brain dead is it?
For example so how does the machine knows that half an hour is equal to 30 minutes? What is the relationship between 30 minutes and half an hour? So it's actually done using a technique called WordNet. Okay, so what is WordNet here? It's actually a lexical database. Okay, that to store all the lexical. Lexical means the meanings, the words. Store all the lexicals in using so-called synonyms, antonyms, hyponyms. You know what is synonyms? Synonym is like the words that having similar meanings. Okay, for example, happy, excited. So this is the synonyms. Happy and sad is the antonyms. Okay, so this is the synonyms. Okay, we have hyponyms. Okay, we have hyponyms. So what is hyponym? What is hyponym? Hyper is a kind of a concept, for example, flower. Okay. Hypo is a subclass to the flower, for example, rose. Rose is a hyponym to the flower. Flower is a hyponym to the rose. So the word net is built through this kind of concept, through the hyponyms, antonyms, this and so on and so forth. So look like this word net. It's a net that consists of all the lexicals or the word nets. For example, if you search for the book, it will relate you to the novel. Why? Because in the word net here, there is some relationship between the book and the novel. Same goes to the half an hour. Okay, so there is a relationship between half an hour and 30 minutes. So that's why in the Google, if you type half an hour, it will return you some response related to 30 minutes. Okay, because there is some relationship. So who built this word net? It's actually built by one of the university called Princeton University. Some researchers, they find all the words, they understand the meaning, and then they build the word net and then they put it inside the Python library NLTK, then you can use it. For example, I'm going to show you one here. Okay, let's say word net is also one of the very powerful so-called lexical database in NLTK. So let's say now I'm trying to ask half an hour. Okay, so what is the synonyms of a half an hour? If I run this code, so it will return me 30 minutes. So there is a relationship between half an hour and 30 minutes. So no matter you ask 30 minutes, the machine will know that, oh, this is actually half an hour. Okay, there is some relationship between these two terms. Okay, so there's no antonyms for the half an hour. The synonyms in the word net is called syntax the syntax. It's just a terms. Okay, so that's why knowledge representation is very important. It's very important that how do we actually represent the knowledge from the unstructured data to the structured data, so that the machine can understand the so-called meanings, but not through the actual meaning, but through maybe the relationship, through the comparison, through how you represent the knowledge. Okay, you will represent in the wrong way, then the machine will interpret wrongly. So one of the reasons why you need this one is for the machine to interpret, to analyze, and come up with the conclusions. Okay. All right. So there are several techniques to represent the knowledge. Okay. One of the famous one is called semantic networks. Okay. Semantic network is a network to show all the semantic. What is semantic? Semantic means the kind of words or the meanings. So you have a network to represent all the semantic, all the relationship. What is conceptual graph? So we have a semantic networks, conceptual graph. We have an or graph. Okay, and the last one is the frames. So each technique here has its own purpose, So normally we use a semantic network and conceptual graph to show the relationship between the concept. For example, what is the relationship between happy and sad? And what is the relationship between excited and happy? Besides, we also use the semantic network or the conceptual graph to show the sequence of events. Okay, for example, today you play games, so inside the game you fight with the boss. Okay, after the boss you win the reward. So it shows the sequence of events. Okay, so we use an and or graph to represent the rule base, to represent rule base. Okay, we have an example later. And last one, we have a frame. Normally we use a frame to represent the properties of one object. Okay, so frame is not suitable to represent relationship or sequence of event, but it's more suitable to represent properties. Semantic net and conceptual graph is not suitable to represent properties because you're going to have a lot of branches here. So let's see the example of semantic networks. So this one is not important here. So what is semantic networks? Is to show the relationship to other concepts. So under the concept semantic networks, there are several terms that you have to take note. The first one is called nodes. I think it's shown here. Yeah. The first one, nodes. Node here is to show the concept. Okay, so this is the node to show the concept. This is the concept. This is the concept. And then the second one, we have this so-called edges of the label arch here. Okay, so we have a label arch here. Okay, normally it's a binary relationship. It's a binary relationship. So this arch here to join the concept, to show what is the relationship between the concept A and the concept B. Okay, and lastly, you need to provide the label for this label arch. What is the relationship between A and B? A is a subclass to B. That is show the relationship between the concepts. Okay, so look at these examples. We have a human, right? Human is a mammal, right? What is mammal? What is mammal? You know Chinese, right? What is mammal? What is the properties of mammal? Vertebrate. Yeah, you have a backbone. What else? Don't know. Forgot already. Yeah, science. So human is a mammals. Other type of mammals like monkey, alligators. So human is a subclass. It's not an example, but it's a subclass to the mammal. Okay, mammal is maybe a superclass. Okay, then we show the relationship between human and a nose, right? All the human we know that has a nose. Then we have a concept here, shown by notes. Then we have a so-called the edge here to show the relationship. Human has nose. Then we have another so-called example or the instant. Okay, Simon is the instant to the human. So Simon tutorial group maybe in L1, and the Simon the favorite number is 8. Okay, so there's no such standard syntax for semantic networks. As long as the relationship here is logic, then it's considered correct. You can use your own so-called the terms here, right? Maybe Simon, a tutorial group, okay, can also. Simon, lucky number, can be, okay. So it's up to the user how to define the terms, the relationship. But somehow, but for the is and instant, you have to take note. So it's quite different between is and a instant here. Is so a subclass. Human is a subclass to the mammal. Maybe you have a monkey is a subclass to the mammals. But Simon is just one of the examples. For example, you have Jason is instant to the humans. Me is instant to the humans. You have a vehicle. Vehicle is a class. Then maybe MPV car is a subclass. It's a subclass to the vehicle. Aeroplane is a subclass to the vehicle. Okay, and then you have a lorry, it's a subclass to the vehicle. So what is an instant? You have maybe a car plate ABC 1, 2, 3, 4. That's car plate 1, 2, 3, 4 is an instant. It's an instant to the subclass called car. Okay, so there's a difference between instant and is a. Okay, so Xin-Chan is 5 years old. Is Xin-Chan still 5 years old now? Anyone? Xin-Chan fans? Yeah, you. How old is Xin-Chan? 5. Forever 5.
Yeah.
Why?
Because it's that.
Why forever 5 years old?
Don't know. American cartoon Simpson also
Simpson.
forever.
Okay. But I'm not favorite of Xin-Chan, so a bit rude, Xin-Chan, a bit hams up. Yes, I never watched. I know that it's very hams up. Okay, so it's 5 years old. So how to represent this in the semantic networks? So we know that Xin-Chan is one of the concepts. 5 years old is one of the concepts. So we want to join these two concepts together. So Xin-Chan, 5. Okay, so age here. So and then you have to take note on this the error here. So we cannot put the 5 back to the Xin-Chan. It doesn't make sense, right? So we know that Xin-Chan age is 5 years old. If you put the errors in the another way around, then it's something wrong. It's wrong. Okay, Tweety the bird can sing. So we know that Tweety is a concept, bird is a concept, sing is a concept. So we can put Tweety. Okay, Tweety is one of the example. It's instant to the bird. So this Tweety can sing, right? So if you don't want to put the can, also you can put ability. Ability sing. Yeah? So it is very freestyle. You use the semantic networks. So why semantic network is very important? One of the reasons is it helps the machines to analyze or to interpret the concept between each other. For example, if you go to the Google search, you type what is ostrich. Then based on this map, the Google will turn you ostrich is actually is a bird, okay, which can run and it is very tall. So it will show this relationship, then it will return you the proper message back to the user. Then you will type what is animals? Maybe it will say animals can breathe, has these properties, has skin, can move, and then it will provide you some other examples. What are the example of animal? Then it will provide you a bird, fish, and so on and so forth. Okay, so this is one of the this is how the so-called the search engine works. We have this map, so the so-called engine will try to analyze. You're looking for animals. So what are the concepts that link to animals that it will return you? It will return the result to you on the page, in the Google search page there. Okay, so this is one of the examples of maybe questions. Represent the terms below in one semantic network. Edward is a vampire. Edward's girlfriend. Bella is a human. Jacob is a werewolf, and Bella are childhood friends. So werewolf is an enemy of for vampires. Anyone?
我很奇怪，有吸血鬼，有蓝的。
You got the two dimples here. Anyone? Nearby? Outside lah, easy to walk. Blender can. Draw some picture for this question one. Semantic networks. Okay, good. Brandon is a vampire. Brandon girlfriend. What is your girlfriend name? Nicole is a human.
Brandon 是吸血鬼吗？他没有吸他的女朋友。哎呦，很有了，多厉害！突然就上了火车，突然这个时候讲。
Brandon is a hamster though.
Brandon has 10 years experience.
Of what?
Anything.
要 is a 还是 is 最好
Sexual harassment.
哪里这么多 access？ 觉得是机会呢，再错这个名我就不拿了。你看讲什么？我以为他有拿这个很好。
Thank you very much.
In love. Edward's girlfriend.
My girlfriend broke up. Okay. Okay, thank you. So let's see. Okay, Edward is an empire. So Edward is instant. Edward is a subclass of instant. Instant, no? More appropriate to put instant, right? So this one should be an instant. Edward is one of the examples because you have others vampires, right? So just one of the example to the vampires. Okay. So Edward's girlfriend Bella. So what is the relationship between Edward and the Bella? Is a girlfriend of Edward. So Bella is a human. So Bella again is a instant. Okay. So is a human. So, Jacob. What is the relationship with Jacob? Is a werewolf. Again, this is an instant. Okay. So Jacob is a werewolf and he's a Bella's childhood friend. Okay. And the last one is the enemy. Okay. Okay, for vampire. Alright. So it's very simple. If you have these kind of questions, you don't make any mistake. Okay, so you kind of bonus mark. So you have a concept, you have a relationship, you just join the concept using the edges together with the label, a proper label. Okay. So this is one of the puzzle questions. Yes, can't raise. So this is just one of the example. This is instant. Okay.
Can we say that the sauna and the water heater is an instance of facility?
They are actually one concept. They're actually one class. They're actually one. They're considered because under the facility there are so many classes. You have what sauna. You have a water heater. Maybe you have so-called the washing machines. But then under the washing machine you have maybe washing machine, the brains, kins, and then model ones. Yeah, so that will be the example. Okay. All right. So it's not difficult, right, for semantic networks. So it's quite simple. As long as you identify the concept, the ideas, then you can actually join the concept together. Okay, so we have more questions here. So again, like you have a university is one of the top 20 university, established in 1950. So blah blah blah. So this one I let you try it at home lah. You try to identify the concept as well as the relationship. This one you do yourself lah. Okay, so I just want to show you how do we build this semantic network using the Python. Maybe you got okay, we learned this theory, then how? So how to put it inside the Python or how to build the semantic networks. So one of the example is the word net that already built by someone by this Princeton universities. So how about, let's say now we would like to build our own semantic networks. So there's quite many library variables in the Python here. One of the famous one is called network X. So one of the library that you can use to build the relationship. Okay, let's say now we like to have a relationship dog animals. So that is animals, cat is animals. So animal is a mammal, right? So that's how we learn about the animal is a mammal. So this is where we add the relationship. So this is just a graph, right? How do you want to draw the graph using a thick, how thick of the edges, okay, and so on and so forth. So if I run this code, then you will see, okay, so you will see this semantic network. Animal is a mammal, okay, dog is an animals, cat is animals, okay. All right. So is there any questions so far for semantic networks? No. Okay, good. Then I will proceed. So this one we have learned just some examples of semantic network. Let's say you have a lower, the dog bite the Peter, the postman. Then you can say, okay, rower is just one of the examples. So instant to dog. So rower bite the Peter. Peter is just one of the example to the postman. Okay, so you can actually extend or modify this simple semantic network to a more complicated one. You treat this byte here as one of the event. Instead of just one of the relationship, you treat the byte as one of the event into this. Okay, you treat the byte as one of the event, and then you have you can create one subclass or one example. It shows that this big B here is one of the example. So in this event here, who is the agent? Lower. What is lower? Lower is the example. So inside this event here, who is the victim? Peter. Who is victim? Peter. Peter is one of the example to the postman. So there's no wrong or right. You can use this way or you can use this way. Okay, it's up to you. Okay, so this is non-quantified semantic networks. Non-quantified means that the event is specific. You know that rower will bite the Peter. But sometimes you may have some statement, a general statement that shows that it's a quantified statement. For example, every dog bite postman. Okay, it is a general statement. So if you have a quantified so-called quantified terms in your statement, for example, every dog, some dog, then you cannot use a simple semantic network to represent the knowledge. Instead, you have to use a partition semantic networks. You have to use two different semantic networks to join them together. Okay, so we can actually draw the semantic network for dog has bitten the postman first. Okay, so this every here is actually a quantifier. So we leave it, we leave it first. Okay, we draw the semantic network for this part. So we know that this is a byte event. So B is the instant of the byte, and then inside this event, who is the agent? Okay, we have a D here. So what is D? Is an example of dog. Okay, what is P here? Is just an example of postman. So this is one of the semantic network. Then we create another semantic network here. We know that this is a general statement because it's not specified by the previous case. So we know that every dot. Then we create a general statement. And then G here is just one of the example. G is an example to the general statement. And we point this general statement here to this semantic network to join these two together to show that, okay, this general statement form this event. At the same time, you have to find which so-called concept is having a quantifier. Let's say this is dot, every dot here. Okay, every dot. Then we join this every here into the example and this D here. It shows that every dot. So this symbol is referred to every. So it means that every dot by the postman. Okay? But this is not very important. Just additional information to you. If let's say we have a so-called the quantifier every. If you have a sum dot here, okay? Sum. Then you have to use this symbol. So this is all. Okay? So let's say now you have every dog has beaten every postman. Okay? If you have every dog has beaten every postman, in this case, then you have to join this statement here. Okay, create one line to show, okay, all postmen, all dog here, and then at the same time you create another line to link to this postman and put this symbol. Then from this diagram we know that every dog has beaten every postman. Okay, is that clear? Okay, so what? Okay, just now we learned about binary predicate, which is the direct relationship. For example, the first one, Ronaldo, Real Madrid. Okay, so we have a Ronaldo, Real Madrid is very simple. Then you have a two concept here. Okay, Ronaldo, maybe team is Real Madrid. Okay, this is binary. But let's say now we have a non-binary predicate. What happened? So this second example here shows non-binary predicate. You have a three concept here. Real Madrid, MU, and 1-3. Okay, it means that in one event you have a three predicates, three objects here. So how to generate the semantic network for this case? Then you have to think a keywords that how to join the concept together. In this case, I'm going to use a keyword called features. Okay, features is one of the subclass to the football game, and then you join the three predicate here. You have a Real Madrid, MU, and 1-3 here. So we know that away team is Real Madrid, a home team is MU, and score is 1-3. If you cannot think the keywords that how to join this predicate, then you can just use the terms called event. Okay, so event is just one of the example. For example, in this case, John gave the book to Mary. So we have a John, a book, and Mary. Right, three predicates. So this event is about give here. So we can just click a one keyword called event. So what is this event? This event is actually one of the example to give. Okay, so in this event, who is the agent? John. Okay, so who is the receiver? Mary. Right, Mary is the receiver. And what is the object here? Book. Okay, book here. So you can just write the name of the book lah, and then book 69 is one of the example to the book. Okay. Yeah. So if let's say now you have a question here. Simon has one. Okay. So based on this semantic network, then you can tell, oh, Simon is actually a human. Simon has nose. At the same time, Simon is a mammal and has skin. Then based on the third question, then you can say, oh, Simon has nose and has a skin. And this is how a machine interprets also based on the semantic networks and return the appropriate response back to the user. Okay. So sometimes we use semantic network to compare the two objects. For example, in this case, okay, so we want to compare the height of Dave and also the Steve. So Dave Okay, so you can point to the H1, it just create one variable here. Okay, it shows that this is just one of the so-called variables, and this variable is greater than this variable. Then you can put a value here. What is the relationship between these variables and this value? Okay, 160, then it's greater than. Okay, so there are many ways to represent the semantic network. If you don't want to create the two variables here, then you can also put maybe if you don't want to create this variable, maybe you can write in such a way. And div, okay, the relationship between that and so this is a value, maybe 160, right? Okay, and then you have another concept called div. Okay, also you have a height 158. So this is greater than, also can. It depends. It's a very flexible to use semantic networks. Okay. Okay, so this is just a prologue. Forget about this. It's just one of the techniques. How do you code your knowledge? After you prepare the knowledge, right? After you prepare this, you have to put this into the coding. Just like how I put the code inside the network X just now. So what is the advantage of and also the disadvantages of the semantic networks? Easy to visualize, right? By looking at the semantic net, then you know what is the relationship between one and another. So related knowledge is easily categorized. The knowledge engineer can arbitrarily define the relationship. Limitations is no standard. As I mentioned, it depends. Every user may have a different interpretations, use different keywords to represent the concept, and it is not suitable to describe the attributes. Remember, it is not suitable to describe the properties or the attribute. Okay, it is not suitable. Okay, so next one we have a conceptual graph. So I'm not going to details about talk about the conceptual graph. The ideas of the conceptual graph is about the same as the semantic networks. Conceptual graph used to represent the relationship, but the difference here is semantic network is more towards a binary relationship. Okay, binary graph is to show the simple relationship. But the conceptual graph here is mainly used to show a more complicated, complex relationship using a bipartite graph. Okay. Okay. If you know that semantic network is good enough already. Well, this conceptual graph is just additional information to you, how to represent the knowledge in a more complicated way. One of the main difference between the conceptual graph and also the semantic network is the node. Right. Just now we have a node to represent the so-called concept, and then we have an edge here to show the relationship. By using the conceptual graph, we want to transform this into this. Okay, Ronaldo. Okay, so team Real Madrid. So this is by using a conceptual graph. It's using semantic networks. So we have to use a node to represent the relationship instead of just hang upon these edges. This is the only difference. Okay? So something like this. So just now we just put the arrows and they put the relationship. But in the conceptual graph, we have to represent the relationship using the what? Using the nodes. This is the only difference. If you would like to know more about the conceptual graph, then you can explore by yourself. Okay, I'm going to go to the third one. It's called end-of graph. So end-of graph, also known as the hypergraph. Sometimes it's called as the inference networks. Infer means that to interpret. Okay, so mainly end-of graph used to represent the rules. To represent the rules. It's not the relationship, but more toward the rules. Okay, let's say now you have these examples. Okay, so this is actually a rule base. You have 3 different rules here. If John smiles, then he looks handsome. If John is tall and strong, then he looks handsome. If John does exercise, then he is strong. Who is John? Anyone named John? No. Okay, so let's see how to build the NO graph using these three rules. If John is smile, so this is the first condition, smile. Then he look handsome. Then we put an arrow here. So handsome. Okay. So look at the second one. If John is tall and strong. If John is tall and strong. Okay. John is tall and strong. So if we have a keyword called and, if we have an and, then we put a join here. Okay, to show that you have to fulfill these two conditions in order to give you this conclusion. So we don't have a join here because rule 1 and rule 2 are separated. Separated. Then the third one, if John does exercise, then he is strong. So you does exercise, then you are strong. So this is the end of graph to show the condition, which condition that can lead you to the conclusions. Okay. Okay, so you have this exercise or not exercise questions here. Can you try these questions? It's one of the passive questions. Before you zoom in the answer you try yourself first, then and you compare. Okay, so forget about the CF value here. So this is so-called certainty factors that you're going to learn in the chapter 12. Forget about this, You just based on these three rules, build the NO graph or the hypergraph. Okay, to test your understanding. So I'll give you about 5 minutes now, 5 minutes. Engine is noisy. Okay, so join together. Okay, then you give overall is poor. Okay, and the last one. Rule number 3, the car service doesn't follow the maintenance and the overall condition. Okay, very good. Simple. Okay, so if you have this kind of question, make sure that you score also lah. You just need to identify the conditions and also the conclusions. Okay, very good. So last one will be the frames. Frame is about the same like you build the class, the class diagram using the word Java. Have you learned about Java, the class? What?
Object oriented.
Object oriented. Then you build the class object. Yeah, it's about the same like that one. I didn't learn, so I don't know how it's look like, but I know that it's about the same. You have a class here. So the purpose of the frames is mainly used to represent the properties or attributes. Okay, properties or the attributes of one concept of one object. Okay, so this is the example of how the frame works. So remember, to build the frames, there are 3 important elements you have to include. The first one is the class name here. Is a computer. So this is the name of this class. So you have to indicate here. The second element is the attribute, the properties. Okay. The third element here is the value here. Is the value. If you don't have the value, you can just actually leave it blank. Okay. You don't have a value, you can just leave it blank. And in this case here, we know that you have a class or superclass called computer, and we know that computer you have a stereotype of attributes called models, processor, memory, price, and we have an arrow to show a relationship. Okay, ASUS is just one of the so-called examples of a computer. Okay, so ASUS, the superclass of ASUS is computer, and then you have you can actually put the so-called value. Okay, what are the properties for the ASUS? So what is the advantages for the frames here? It's more structures and organized, and you can't actually use the semantic network to represent this. Can, but it will be very messy. Try to imagine that how are you going to convert this computer to the ASUS? Then you will have a lot of nodes here. You have a computer. Okay, then you join to the ASUS. Okay, then you have a lot of properties. Okay, and then computer you have also the all properties, the default properties. What if let's say computer you have events? Okay, this is just one of the examples. You have other brands, right? Then your map will be very big, and it is not suitable to use frame to represent the to use a semantic network to represent the attributes or the characteristic. Okay, so what is the advantage here? Is more structured, organized to represent a stereotype object. What is stereotypes? Do you know what is the meaning of stereotypes? Stereotype means what? Means it's the typical properties. Like when I say a female, so what is the properties that first come in your mind? Female, long hair, huh? Stereotype. I don't mean that short hair is not like female, but I mean the stereotype, the first the ideas that come into the mind when I say what is the properties of female. Then you say okay, long hair, fast skirt, okay, sweet smile. This is the stereotype properties. Okay, typical one, typical ones. Okay. Describe various attributes and characteristics of object and real-world entity. So implicit connections of information in the problem domains. Okay, it's not only to show the properties, but it's also show the inheritance, right? This answer is actually inherit from the property from the computer. Okay, so remember you have three elements: the name of class, the attributes, and also the values. Okay, so let's say this case, another example. You have a birds, right? So birds is actually what is the properties? Have a feathers, locomotions, can fly. Okay, and then you have an ostrich. So you can put is means that we know that this frame, this is actually one frame. Ostrich is actually a subclass to a bird. So bird is a superclass. Ostrich is a subclass, and the locomotion is walks. Okay, mammals, walk, hair, locomotion, walk. So this is another so-called class here. So if you compare to the Java, you want to create so-called subclass, then you use extend, right? You use extend here. So if you want to create the instance or examples in the Java, you use a keyword called new. Right? You still remember lah. Okay, so it's about the same. It's about the same. It's mainly used to represent the properties. If you're very good or if you learn about the Java, then shouldn't be a problem for you to build the frames. Okay, so this is another example. Yeah, computers. This is not an example. Same like previous one. So you can actually further extend the class, the frames previously into this format where you add two more informations. The first one is called data types, right? So you want to show what is the data type for this value, then you can include. Okay, so this is actually a string. 2 is actually a number, numeric, then you can put an n here. So 1 billion is actually a numeric, then you can put an n here. So this is just an additional information. It's optional. You don't put also a name actually. Okay, the second information that you can put inside a frame is called a facet. Okay, so facet here is to add the information. So what is the meaning of these two? What is the meaning for this 1 billion here? So default here, it means that when this bird borns, right? So we know that by default it has 2 wings. So what is initial means that this initial means that at this moment you have 1 billion populations of the so-called the bird. Maybe after 10 years, it reduced to maybe 1 million. So the value can be changed. Okay, but the default cannot be changed. We know that by default human we have 2 legs, 2 hands. But initial means that the population maybe after 5 years the population of human in Malaysia maybe reduced from 1 million to maybe 5 million. Initial is a value that can change. Okay, but again it's optional that you want to put the data types or you want to put the facet. Okay, it's up to you. But the 3 elements that you must include will be the class name, the attributes, and also the value. Okay. So what is the disadvantages of frames? It is very difficult to program, especially making inference. Unlike the so-called the semantic network, is easy to make inference. Right? What is the Simon just now? Simon has no. So look at the map, then you know that what are the properties that Simon has. But by having this frame, it's very difficult to make inference. So this is one of the examples that I can create the frames in the Python. Okay, I'm going to show you one example here. So not this one. Okay, this one. Okay, so I create a class called car frames. Okay, so this is the name of a class, and then I have a so-called the attributes, right? Manufacturers, models, year, colors, engine size, and then none here is means I don't have any value at this moment. I just put a none. So this none here is referred to the value lah. Okay, so you have a class name, attributes, and also the so-called values. And then I create the instance, right? Car instance. So this is just one of the examples. So this car instance is inherit from the superclass called car frames. And then under the car instance, I have this so-called attributes. Then I can insert the value. So this example of this car is actually a Toyota Camry from 2022. The color is blue and so forth. Okay. So compared to the semantic network, it's more organized, it's structured, but it is very difficult to make the inference compared to the semantics. Okay, and also the limited not suitable to describe the sequence of event. Okay, so unlike the semantic network, just now what I say is like you have some battles, right? Battle in the game. So you have a game here. Then it can show you have a battles. You want to fight with the boss. Okay, after you fight with the boss, then you have a reward here. Okay, so what is the reward? Maybe some coins, 1 million coins here. So you can show the sequence of the event in semantic networks, but it's impossible that you represent this knowledge using frames. So how can you represent the sequence of event using frames? It's impossible. Okay, and also non-description on syntax semantic of a sentence. Okay, so this is one of the main problems for the frames here. So what is the syntax or semantics ambiguities in sentence? Okay, for example, in this case, I use a semantic networks here. If I have a bank here, I have a keywords called bank. So I know that the bank can have multiple meanings. So this is maybe finance. So maybe this is called a river bank. Okay, then I can further expand. Okay, what is the meaning of finance bank? You have a Maybank here and here. Where's the river banks? Using frames is impossible. You can't represent this semantic so-called ambiguity using frames. It is possible. Okay, incomplete informations. So just now we have learned about a semantic network. We can use a partial semantic network to show the or, okay, and okay, some or dot but or postmate, right? You can draw a semantic networks here, okay, then you can put this or. But using frames again, you can't represent this information. You cannot. Okay, so it depends on the questions. Then you decide which technique to use. Not all the information can be represented by the semantic networks, as same goes to the frames. So it has to depend on the information. So what is the advantages of frames? Easy to understand, right? You have a frame, very organized. You have to deduce the properties of each of the objects, and it's very flexible. You can easily add the class, you can easily add the properties, or easily detect the missing values. Unlike the frame, another semantic networks, if you have a very big semantic network here, you may miss out one of the important maybe elements or the properties. But through the frames, you can easily spot the missing value or the missing properties. Okay, so yeah, I think this one you are better than me lah. Okay, so what is the facet? As I mentioned, facet is to add more information. So what is the value? It can be default or it can be the initial. Okay, like the case just now. Okay, so slot. What is the slot here? Slot is referred to this. Okay, so in slot you can do many things. You can put the value. Okay, if you don't have the value here, for example 1 billion 2, you can leave it blank. Okay, otherwise you can also add description. For example, in this case, if you don't have a value, you can also add a description for the particular attribute. For example, team. Team is a class, the cardinality. Okay, so you can also add the description here if you don't have any value. Okay, another one here is you can use the slot as one of the class. Okay, you can treat the attributes of one subclass as another class. For example, in this case, let's say you have a baseball team. So inside the baseball team, you have several properties like cardinality, team size, and managers. So this manager here, the property itself can be another subclass. Okay, then you can further analyze, further so-called describe what is manager. So manager is what, so you can put the names, okay, you can put the numbers, you can put the location, and so on and so forth. Okay, and then the lastly is the daemons. So daemons is in the Java is called methods, right? Methods. So what is the purpose of these daemons here? So if you refer to the previous case, the value that we put here is so-called static. We cannot change the value, right? Once we define, then that's the value. So daemons here is used to dynamically modify the value if you have something happens. Okay, let's say now if you have a new value that put inside the slot, then something will be triggered. So it seems like the methods. But for your information, you don't need to memorize the methods inside the frames here. It just show you some of the example. If added, if removed, if needed. Okay, so I'm going to show you the code and how we can actually create the daemons inside the frames. Okay, in this case, let's say now we have a temperature. So this is actually a static value. Then we can create the so-called the methods, okay, or called as a daemons lah, okay, to modify the temperature. So this is the functions, a kind of functions where you can modify the current value to the latest value, or it's called daemon. It's a method. Okay, so if I run this code, so what will happen? So you can actually initially from 0. So now I have something happen. So I can actually modify the value from 0 to 25 degrees Celsius. Okay. So these are some of the examples what you can do on the slot. You can actually put the value. You can also put descriptions. You can also treat the properties as one of the subclass, or you can treat the attributes as a daemons, as a methods. Also can. Okay. So let's continue. So sometimes you may need to convert or transform the semantic networks to the frame. For example, in this case, you have a semantic network. A player is a team. Another is the example of players. Players play football. Okay, so you have to convert this semantic network into the frames. So how to convert? It's very simple. You have to identify how many concepts they are actually joined with this keyword called is or instant. Okay, in this case, in this map here, you have a 3 concept. Team, player, and Ronaldo, they are actually joined with this keyword instant and instant is then we can actually create 3 frames. Okay, team, player, and Ronaldo. Okay, so like this, team, player, and Ronaldo, they are actually connected with is and instant. Then we know that they are actually 3 frames. So after you create the 3 frames here, then you can put what is team? Team is actually a superclass. Okay, so what is player? Player is actually a subclass to a team. So what is the properties under the player? What is the properties of a player? Football. And then what is the properties of a Ronaldo? So it's a team Real Madrid, but I think this is an old slide. Ronaldo is no longer in Real Madrid. Where is it now?
Don't know.
Do you know where is Ronaldo?
No idea.
Where is Ronaldo now? Saudi. I think it's not in the Europe country. It's go to Saudi, one of the football club. Okay. So how about this? So let's say now you have these semantic networks. So how to transform this semantic network to a frames? So as I mentioned, you have to identify how many concepts joined with is or instant. So from here we have bird, kernelly, and treaty. Right, these 3 are actually a concept joined with the keyword is or instant. Then we can create 3 frames: bird, kernelly, and treaty. Okay, so you can create bird, kernelly, and treaty. So because we have a 3 concept here, you can create 3 frames. So bird, what? Bird is animals, right? So it's actually a superclass. You can actually if you don't have the animal here, by right, this animals you can actually remove it. You can change to class. It's a super class based on this semantic networks. Okay, and then the bird can fly and cover the feathers. Okay, so good. Right, you have a kernelly. So you point here to show that there is a relationship between the bird and kernelly. What is kernelly? It's a subclass to a bird. It's a subclass to the bird. So what are the properties of kernelly? Yellow and sound. Okay, and then the last one, you have a treaty. Treaty, what is the? Treaty is an example. Example to the kernelly. So what is the properties? Can talk. Okay, so this is how we transform now the semantic network to the frame, but not often. Not often. Normally, we will represent the sequence of the events or the properties, okay, using the frames, or sequence of event using the semantic networks. Okay, so now let's look at this question back here. Can you try how to put this information or this knowledge using the frames? We have a university, is one of the top 20 universities, so it was established in the 1950. Okay, so it offers 6 programs as degree levels. Okay, as more than 45,000 of students, more than 10 countries, include international students, more than 10. Okay, can you find this using engineering, ICT, accountants, business? So you can create another frame to represent each of these programs. Right, you have 6 programs here. So if you have a value here, then you can actually put. But we don't have a value, so we just put it here. So this 6 program to show that there are actually subclass under this program. Okay. Right, is that clear? Here, so if not mistaken, there'll be one question that's really coming up from here. Let me find out whether I do keep the past questions. It's one the past year, huh? So. This one's simple. It just asks, okay, semantic and frames are commonly used. So explain the differences between the semantic network and the frames lah. Also provide one example to illustrate the semantic network and the frames. So in this case, you can just tell semantic network is more appropriate to represent the relationship or sequence of events. Meanwhile, frames is more towards like to show the properties, right? To show the properties and also the attributes. To provide examples, you can give a very simple example. For example, the treaty is the bird, right? Treaty is the bird. So you just draw the concept as well as to join the concept and provide the relationship. So I want to give you some this one, yeah. Okay, so this is another good example. The information below describe the differences between the desktop and laptop. So you have a knowledge, okay, for example, blah blah blah. So frame in semantic network are common representations. So identify which technique is more appropriate to represent this information. Explain why. After you explain why, then you have to illustrate. Okay, so we know that from here you will have a lot of properties actually, like battery, power supply, large, not portable, okay, more powerful processors. So all these are actually properties. Then you can explain why frame is more appropriate, because you have so-called the class, superclass, and as well as the properties to represent, right? There's no event at all. There's no event. There's no so-called relationship. So it's mainly properties. right? Then you can use frame here. Then after that, you have to illustrate. You have to show how to draw the frames and store the informations inside. So since we have a time here, so can you try these questions? I will rather be specific. What is the properties? Maybe in this case, it's like common user. Okay, maybe I put a common user. Then you can put a student. Okay. So laptop is generally small. So you have two subclasses, which is a laptop and desktop. Okay. So it's a computer. Okay. So it's a superclass. It's a computer. It's a computer. Okay. So instead of put a properties, everything here, you give a name. Okay. Maybe size. Okay. Large. Okay. Portability. Okay. Portability. No. Okay. Power. Supply. Okay. So you have to give. What is a processor? Okay. Something like this. Okay. Yeah. So it will be easy to read. Other than you just put properties, everything here. So you put like this. So in this case, laptop. Okay. Same goes to this one. Size, portability, the power supply, the processor. Then you click another frames here is an Acer. So this is one of the example, right? One of the example. So you can put instant. This one you can put instant. So instant. So you put gaming laptop means that it's actually inherit from different frame. So you can actually put laptop also. You can put laptop. Then you can put one of the properties. Main purpose. Okay, it's a gaming. You can put also gaming laptop, but then if you have a gaming laptop, it means that in between these two frames, you have to click another frame which is gaming laptop. Okay, and then this inherit the gaming laptop. Otherwise, you want to inherit only the laptop, then you just put the gaming as one of the properties. Okay, then yeah. Okay, very good. So just some improvement. Alright. So it's very important that you click the name, the class name here. Okay, so this is the first element. The name. The second one is the attribute. The attribute. The last one is the value. Okay.